Okay, so in this video, we're going to have a look at how to find scientific notation and significant figures. By the end of this lesson, we'll be able to write numbers in scientific notation, round numbers to specified significant figures, and combine both of them together. So number one, writing numbers in scientific notation. Why do we write numbers in scientific notation? Well, we do it because it makes it a lot easier to compare very large or very small numbers. So if we were asked in question A, which one is bigger, or in question B, which one's bigger, it's very hard to do easily unless if we count all the zeros. Counting all the zeros will take time, and so that's why we have scientific notation to make it easier for us to identify which one's bigger, which one's smaller. So let's have a look at a few examples. In question A, we have 8, 5, 3, and 8 zeros. To write that in scientific notation, we have 8.53 times 10 to the power 10. In question B, we have 0.8 zeros again, 79. To write that in scientific notation, we write it 7.9 times 10 to the power negative 9. So it's important to remember that whenever a number is probably more than 1, the power of 10 will be positive. If the actual number is a decimal that's less than 1, then the power of the 10 will be negative. Okay, so just important to remember that. If it's a decimal that's less than 1, the power will be negative. In order to write these in scientific notation, we must always have one digit and then the decimal place. One digit and then a decimal place. And that one digit cannot be a 0. Okay, it cannot be a 0. So in question A here, we've decided to put the decimal place here. That's how we get our one digit then a decimal place. We can write the rest of this, but we don't need to write all the zeros, so we just wrote 0.53. So because we put the decimal place there, but it's actually meant to be here, we need to determine how many digits are in between those two decimal places. When we count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the power is 10. In question B, we put the decimal here to make it one digit and then the decimal. But the actual decimal point is here. Therefore, we need to count how many numbers are in between those two decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9. Therefore, the power is negative 9 because the actual number is a decimal that's less than 1. Okay, so our power will be negative. So let's have a look at some examples. Question A, we have 38 million. I'm going to write it as 3.8 times 10 to the power of 4. I put it here. It's meant to be here. So how many numbers are there in between? 7. Question B, I'm going to write 4.29 times 10. Well, I put the decimal place here. It's meant to be here. How many numbers are in between? 4. But because the number is a decimal that's less than 1, the power is negative. Question C. We have 3.186 times 10 to the power of. We put the decimal here. It's actually here. So how many numbers are in between? 3, 6, 9, 10. Because the actual number is more than 1, our power is positive. Okay, that power of 10 is positive. Question D, 9.267. We've put the decimal there. It's actually here. How many numbers are in between those two decimal places? 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 to the power of negative 9. Negative because the actual number, the basic numeral, is a decimal that's less than 1. That's why the power is negative. So we're going to express each of these as an integer or as a decimal. You can just use your calculator to do this, but I'm just going to go through it without using the calculator. Whenever we multiply a number by 10 or 100 or 1000, etc., we're moving the decimal to the right. The same number of zeros there are that we're multiplying by. So, for example, 1.68 times 10. Because we're multiplying, we're moving the decimal to the right. Because there's 1 0 once. So when we move it to right once, that gives us 16.8. According to question A, we are moving it to the right 5 times. So if we move it to the right twice, that gives us 268. But we need to move it to the right 3 more times, so that we're going to write 3 zeros. In question B, it seems like we're moving it to the right, but instead of moving it to the right twice, we're going in the opposite direction. Okay, so technically we're moving it to the left twice because of that minus. So we move it to the left once. We'll have 0.90137. So we will need to move it to the left one more time. That will give us 0.090137. You can just put this in your calculator if you're not confident with this. 9.0137 times 10 to the power of negative 2. And that'll give you your answer. Question C. We have 1.0 times 10 to the power 4. It's positive, so we're moving right. If we move it right once, we'll have 10. We need to move it right 4 times altogether. So that we need to move it to the right 3 more times, so that's 3 zeros. Question D. We need to move it left 7 times. If we move it to the left once, the decimal will be there right before the 8. So we need to move it to the left 6 more times. That means 6 zeros. 1, 2, 3, 4, 5, 6, and then the 8, 3, 3, 4. Okay, so now we know how to write numbers in scientific notation and vice versa. Let's have a look at how to round numbers to significant figures. So significant figures are used to specify the accuracy of a number. If the number is 0 point something, then every digit is significant except the 0 before the decimal point and any 0 straight after the decimal point. So for example, 0.0012 has 2 significant figures. They are 1 and 2. 0.08090 has 4 significant figures. 8090. This is not significant. And this 0 here is right after the decimal point, so it is not significant. C has 1 significant figure. Okay, this 0 is not significant. And all these zeros come directly after the decimal point, so they're not significant. Question D has 3 significant figures. 7, 0, and 9. This 0 is not significant. And these zeros come directly after the decimal point, and so are not significant. Question E has 2 significant figures. 5 and 0. And question F has 3 significant figures. 7, 0, 0. If the number is a normal number with a decimal, for example, 13.760, so not 0 point, it's any other number other than 0, then every digit is significant except any zeros at the start of the number, because we never write numbers like that. It's very silly to do so. So question A has 3 significant figures. All of them are significant. Question B has 5 significant figures. Question C has 4. And question D has 5. All of these are significant. These 4 are significant. We don't write zeros like this in front of the number. It's very silly to do that. And 640.00 has 5. Okay, again, we don't write numbers like that. If a number has no decimal point, there may be more than one answer to how many significant figures there are. Any zeros at the start are insignificant, because we don't write it like that. But any zeros at the end might be significant, so write every possible answer. For example, 764,000 has 3, 4, 5, or 6 significant figures. This is because we don't know whether it's been rounded to the nearest 1,000, or 100, or 10, or 1. So we have to write all of them. So it could be 3, or 4, or 5, or 6. Question B has 5, or 6, or 7. Question C, we know that that's not significant. So, it has 8 significant figures. All of them are significant. Question D, we don't write those, they're not significant. But it could be 2, or 3, or 4, or 5. So we need to write every single one of them as our answers. Alright, so now that we know how to round numbers to specified significant figures, let's combine the two, scientific notation and sig figs. So we're going to write these numbers using scientific notation and 3 significant figures. I'm just going to write this one in scientific notation first. So that gives us 2.183 times 10 to the power of 6. Except that this has 4 sig figs. I want to write this with 3 significant figures. That means there should only be 3 numbers, 3 digits here. So I'm just going to round like normal, 2.18, like rounding a normal decimal, times 10 to the power 6. And now I have 3 sig figs. Question 4, same thing, 1.9482 times 10 to the power of -3. Except that this has 5 sig figs. I only want 3. So I'm going to round this to 1.95. It's like normal rounding decimals. This 8 turns this 4 into a 5. So 1.95 times 10 to the power of -3. That is 3 sig figs. Okay, so now let's have a look at 2 more examples. I'm going to write these numbers using scientific notation and 4 significant figures. So scientific notation, 5.7089 times 10 to the power of 8. Yep. That's 5 significant figures. So I want 4 significant figures, 5.709 times 10 to the power of 8. Question 2. 5.21067 times 10 to the power of -4. So 4 significant figures, 5.211 times 10 to the power of -4. And that's it for this video.